Have you ever stopped to wonder about the incredible process of planetary formation? Have you ever wondered how planets are made? For centuries, scientists could only guess at the answer, relying on indirect evidence and theoretical models. They were piecing together theories from the planets we see today, our cosmic neighbors. It was like trying to understand how a cake is baked without ever having seen an oven or a recipe. You could only look at the finished dessert, admiring its form and flavor, but missing the magic of the process itself, the transformation of raw ingredients into something extraordinary. We could see planets like Jupiter and Mars, each a unique world with its own story etched onto its surface. But we had never witnessed the pivotal moment, never one in the act of being born. The actual formation process remained shrouded in mystery, hidden behind vast distances and cosmic timescales. That all changed when astronomers, driven by insatiable curiosity, pointed their most powerful telescopes at a young star, HD 135344b, located hundreds of light-years away. And there, amidst the swirling dust and gas, they saw something incredible. A baby planet, still wrapped in its cosmic cocoon, forming before our very eyes. This isn't a simulation or an artist's impression. It's a real image, captured by cutting-edge technology, of a planet in the making. For the first time in human history, we're not just looking at finished worlds, remnants of a bygone era. We're witnessing the construction process live, in real time. We can see the planet pulling in material from the surrounding disk, clearing its orbital path, shaping its surroundings with its immense gravity, and confirming ideas scientists have held for decades about how planets are born. This groundbreaking discovery is like finding the first chapter of a book we've only ever read the ending to, finally understanding the origins of these celestial bodies. Every new image from this distant system is a message from the past, a cosmic echo telling the story of creation happening all over our galaxy, and potentially throughout the universe. It inspires us to keep exploring the cosmos, to keep pushing the boundaries of our knowledge, and asking big questions about our place in the universe. Witnessing a planet's birth reminds us that the universe is not a static, unchanging place, but rather is alive with activity, with new worlds forming in stellar nurseries far, far away. This is more than just a science story or an astronomical observation. It's a glimpse into our own origins, a reflection of the processes that led to the formation of our own solar system, written in the stars. The universe is still creating, still evolving. And now, thanks to the power of modern telescopes, we can finally watch this incredible process unfold before our eyes. Let's embark on a journey to a distant and fascinating star system, HD 135344b. Located approximately 440 light-years away from our own solar system, a vast expanse of space separates us. HD 135344b is a young, vibrant star, still in its relative infancy on a cosmic scale. What makes this star system particularly intriguing is that it's surrounded by a massive protoplanetary disk, a swirling cloud of gas and dust. This disk isn't just a uniform, featureless expanse, it's far more complex and dynamic. It's distinctly marked by two magnificent spiral arms, grand structures that stretch out across vast distances. These arms give the disk the appearance of a miniature galaxy, a swirling island of matter in the vastness of space. These spirals aren't just pretty to look at, they're important clues for understanding the system. They provide evidence that something big is stirring within the disk, disrupting the smooth flow of material. Scientists suspected that a planet, still in the process of formation, was responsible for creating these spirals. The planet's gravity, as it orbits the star, is carving out these beautiful swirls in the disk. However, the star's intense brightness made directly spotting the planet an incredibly difficult task. It was like searching for a firefly right next to a powerful searchlight, the glare obscuring everything nearby. Despite the challenges, the spiral arms became a cosmic signpost, guiding astronomers in their search. They were subtly pointing to a hidden world, a planet shrouded in the star's brilliant light. Astronomers realized that if they could somehow block the overwhelming glare of the star, they might finally catch a glimpse of the planet that was actively shaping the disk around it. As a result, HD 135344b quickly became a top target for planet hunters around the world. Its mysterious spirals held the key to unlocking a deeper understanding, to witnessing the incredible process of a new world coming into existence. The challenge of observing this system was immense, requiring cutting-edge technology and innovative techniques, but the compelling clues hidden within the spiral arms were simply too enticing to ignore. This unique system offered a rare and invaluable chance for astronomers to essentially catch a planet red-handed in the very act of its creation. The mystery surrounding the origin of the spirals and the planet lurking within was about to be solved. And with that solution, a new and exciting chapter in our understanding of the cosmos, a new era in the study of planet formation and exoplanet research, would undoubtedly begin. How does a planet begin its long journey? What are the initial steps in the cosmic dance that leads to the formation of these celestial bodies? It all starts within the swirling expanse of a protoplanetary disk, a vast arena of dust and gas surrounding a newborn star. Here, amidst the chaos and energy, tiny dust grains, far smaller than grains of sand on a beach, begin their slow, patient orbit around the young star. Through electrostatic forces and gentle collisions, these grains begin to stick together, forming loose, fragile clumps. These clumps gradually grow into pebbles, slightly larger and more substantial. Then, the pebbles coalesce further, becoming rocks, a fundamental process known as accretion, where small particles merge to create larger bodies. As these clumps grow in size and mass, their gravitational pull increases, exerting a stronger influence on their surroundings. This increased gravity attracts even more material, leading to frequent collisions that fuse the rocks together, forming larger and larger boulders. Over vast stretches of time, spanning millions of years, these boulders continue to merge and accumulate, eventually transforming into planetesimals. These planetesimals are the essential building blocks, the fundamental components from which planets will ultimately be constructed. Among the multitude of planetesimals, some become large enough and massive enough to dominate their surrounding region of space. They begin to sweep up surrounding material with their powerful gravity, acting like cosmic vacuum cleaners, clearing their orbital paths. It is at this pivotal stage that a protoplanet is born, a planetary embryo taking shape. Its gravity becomes strong enough to pull in vast quantities of gas and dust from the surrounding disk, further increasing its size and mass. Giant planets, such as the majestic Jupiter in our own solar system, typically form through this process of gas accretion. They build up solid, rocky, or icy cores first, before accumulating their thick, swirling atmospheres of hydrogen and helium. The entire process is inherently chaotic, with countless planetesimals facing destruction through collisions or being violently ejected from the system. Yet, amidst this cosmic turmoil, the survivors endure, gradually evolving into the fully formed planets we observe today. By meticulously studying protoplanetary disks, such as the one surrounding the star HD 135344b, we can witness this remarkable recipe for planet formation unfolding before our very eyes. It's akin to observing a vast cosmic construction zone where the raw materials of planets are being assembled. This allows us to gain invaluable insights into how worlds like our own Earth were painstakingly built over eons. A deeper understanding of this intricate process is absolutely key to unraveling the mysteries of our own origins and the formation of our solar system. By carefully watching and analyzing these distant disks, we are privileged to witness the universe's grand planet-making endeavor in real time, a truly awe-inspiring spectacle. Observing a baby planet 440 light-years away is no small feat. The parent star's brightness overwhelms the faint planet beside it. Astronomers use a coronagraph, a high-tech sunshade inside the telescope, to block the star's light, creating an artificial eclipse. The European Southern Observatory's Very Large Telescope, VLT in Chile, equipped with the SPHERE instrument, made this possible. SPHERE combines a coronagraph with adaptive optics, correcting for Earth's atmospheric blur to deliver sharp images. The team, led by Anthony Baggallini, searched for a warm, glowing dot, infrared light from the forming planet. They collected data over time, using computers to subtract the star's glare and track any moving object. A true planet would shift position, unlike distant background stars. By following this faint moving spot, they confirmed it was a planet in the making. Technology and patience finally let us see a world being born. After years of effort, astronomers found it, a tiny point of light inside the spiral arms of HD 135344b's disk. This was direct imaging, capturing the planet's light, not just inferring its presence. Most exoplanets are found indirectly, but this was a rare, direct glimpse of a planet still forming. The planet HD 135344b orbits far from its star, stirring the disk and creating grand spiral arms. It's a giant, likely several times more massive than Jupiter, still growing as it pulls in material. Studying its brightness and temperature, scientists can estimate its mass and growth rate. The discovery confirms theories. A massive planet should create spiral arms, and here, both are seen together. This real-life laboratory lets us refine our models of planet formation. Each new detail from HD 135344b sharpens our picture of how worlds are born. Direct imaging has changed the game. Now we can watch planets emerge. Watching a planet form around HD 135344b is like peering into our own past. Our solar system began the same way. Dust and rock swirling in a disk around the young sun. Rocky planets formed close in, while giants like Jupiter grew farther out, shaping the system's layout. Jupiter's gravity carved gaps and stirred up material, influencing everything from the asteroid belt to Earth's own history. By studying systems like HD 135344b, we see echoes of our own origins. These discoveries connect us to the universal story of creation. The universe has more than one way to build a planet. While HD 135344b showed one method, another star, V960 Mon, 5,000 light-years away, revealed something different. In 2014, V960 Mon erupted in brightness, lighting up its disk and letting astronomers see its structure in detail. The disk was clumpy and fragmented, with chaotic spiral arms breaking into massive clumps. Some clumps were large enough to become giant planets, potentially forming several at once. Instead of a single planet carving a path, here, planets might be born from collapsing arms of gas and dust. This was the first strong evidence for a different planet-making process. Nature, it turns out, has more than one recipe for worlds. The universe's creativity in planet formation is greater than we imagined. The process at V960 Mon illustrates gravitational instability, a fast, dramatic way to form planets. If a protoplanetary disk is massive and cold, its own gravity can cause it to fragment into dense clumps. These clumps collapse quickly, forming giant planets in just thousands of years. This top-down process contrasts with the slow, steady core accretion seen elsewhere. Both methods likely operate in the universe depending on disk conditions. This explains the diversity of planets, some born slowly, others in a cosmic rush. For distant, massive giants, gravitational instability may be key. Nature's toolkit for planet building is more varied than we ever thought. These discoveries do more than teach us astronomy, they connect us to the cosmos. We now know the process that made Earth is happening across the galaxy. Each new planet we see being born adds to our understanding of our own origins. The diversity of planet formation means worlds come in all shapes and sizes, some may even resemble Earth. With new telescopes, we'll study these baby planets in greater detail, uncovering more of the universe's secrets. Watching planets form is humbling. It reminds us we're part of a vast, ancient story. We are stardust, shaped by cosmic processes, now able to look back and wonder. These discoveries are about us, our curiosity,